Shining water. Light is known to behave in a very predictable manner. If a ray of light could be observed approaching and reflecting off a flat mirror, then the behavior of the light as it reflects would follow a predictable law known as the law of reflection. The diagram below illustrates the law of reflection. In the diagram, the ray of light approaching the mirror is known as the incident ray, labeled I in the diagram. The ray of light which leaves the mirror is known as the reflected ray, labeled R in the diagram. At the point of incidence, where the ray strikes the mirror, a line can be drawn perpendicular on the surface of the mirror. This line is known as a normal line, labeled N in the diagram. The normal line divides the angle between the incident ray and the reflected ray into two equal angles. The angle between the incident ray and the normal is known as the angle of incidence. The angle between the reflected ray and the normal is known as the angle of reflection. These two angles are labeled with the Greek letter theta, accompanied by a subscript read as theta I for angle of incidence and theta R for angle of reflection. The law of reflection states that when a ray of light reflects off a surface, the angle of incidence is equal to the angle of reflection. This principle often is used for angular magnification. Let us see the application of the law of reflection in a milky bulb. The materials required are a glass jar or wide-mouthed bottle, torch light, milk, spoon. Procedure: take the wide-mouthed bottle or the glass jar and fill it with water. Place a torchlight above it. The light should fall into water and not on the walls of the water. If you look into the water from above, we will see some shine in the water. However, the outer surface of the bottle would look darker than before. Now, add 2 or 3 spoons of milk in the water. Mix the milk well with the help of the spoon. Now, pass the torchlight again and observe the difference. You will see that the shine inside the bottle has increased only a little. But the outer walls are so bright that the bottle glows like a milky bulb. How is it so? When the torch is lighted, the angle of incidence of light is very small, acute angle, and in agreement with law of total reflection, the entire light remains confined inside the jar. But when some milk is mixed with water, the light thrown from the torch strikes the molecules of milk floating in the water. The light which strikes the molecules gets reflected, and the reflected light coming out through the transparent wall of the jar creates brightness inside the jar as it shines outside on it.